right. We got 3 viewers. Yes. 3 is better than 0. Hang on. What have we got? All right, folks, I'm just going to give about a few minutes. I think we'll start at 10 past 8. What is the time right now? Just need to sort out a few questions. And then once I sort out a few questions, we will actually get started. Clock. There we go. What do we got? Complex. No, differentiation. Differentiation. Awesome, Carrot. Yeah, how you going? Awesome. Oh, actually, messages. Comments, blah, blah, blah. Yeah, I'm all right. I forgot about the what do you call it? Okay, I don't think I can change it anymore. Okay, now here we go. I can change it. Save. There we go. Anybody can message now. How's school? Awesome. Had to change a few settings. Yeah, well, you know what? It is what it is. Well, I'm sure it'll get fine soon. I don't know how long this series is going to take, because I think the last time I over-predicted it to 15 hours. So if it's 15 hours, I reckon we'll be done in 15 sessions. Hoping to go for like just one session, 1 hour. We'll see. Have you started doing differentiation already, Garrett, at school? What? Have you already finished differentiation? I'm surprised that you're doing integration so early. Wow, okay, that's really interesting that you're doing integration first, because there are some parts I'm sure you would. Oh, okay. I've never heard of that way before. Usually folks do like complex numbers first and then differentiation and then integration. That is the first time I'm hearing someone doing integration first. I'll have to edit all of this out so that we can start at 8:10 properly. What? That is strange, awesome, I have to say. Like, I've not heard something along that lines. But you know what? If it works, it works. While we're doing that, let me get some exam questions ready as well. What? 9-1. I have no idea. What is the differentiation standard? 578. I thought it was. All right, folks. So 8:10, we're gonna kick things off here. So welcome to the first differentiation in I don't know how many hours is gonna take. That's why I put as question mark. So we will basically do how this whole series is gonna work is that we'll cover most of the content, and well, I think we'll cover most of the content. But what I'll try and do is I'll teach you guys a couple of concepts every session, and then we'll go straight into exam questions. All right, so we'll do concept, a couple of practice questions, and then we go straight into exam questions. So that's pretty much how I end up doing this particular series. I've had feedback from people before that it's worked for them. So, and I've just taken me 4 years to actually make a differentiation one. So here we go. So I will basically just go through a couple of concepts. I might give you guys some questions, give you some time to kind of do the questions, and then I'll go through the answers with you. And then after that, we'll do the exam questions, all right? So if you are coming from level 2 calculus, you probably would have done some basic differentiation. So today we're just going to do some basic differentiation and one extra new rule that I'll introduce called chain rules. So 2 things we're going to cover today. So we will do a little bit of basic differentiation, and then after that we are going to be looking at something called the chain rule. All right, so 2 things that we're going to cover today. Now, you might actually remember this. Basic differentiation is when you have something like a to the power a times x to the power of n when we differentiate it. There's 2 ways of writing this when you differentiate it. Some people do this. They write it as, actually not 2, I'm lying. There's basically 3 ways. Sometimes what they do is, like, if they do y equals to axn, they would write it as y dash. Sometimes you see it as dy dx. So that's 2 ways of writing this. Sometimes you'll even see something like this, f of x equals to axn. Then they might actually write it as f dash of x. So if you think about it like this, everything in the yellow box is the part that's actually differentiated. All right, but anyway, when you differentiate the function, you end up getting a multiplied by n multiplied by x to the power of n minus 1. Now, if I'm correct, I think this is given in the formula sheet for you folks, but trust me, you will do so much of this that you probably won't even ever think about using the formula sheet. Hey Bowman, welcome. Everybody else, welcome aboard. So with that in mind, what I'll do is I'll do a couple of really quick examples, and then I'll get you guys to do some questions, and then we'll go straight into exam questions, all right? So here is my first example. So basic one. We're going to do basic one, right? So we've got 7x to the power of 3. So if you have y equals 7x to the power of 3, if you've been doing calculus at level 2, you know that you would have already be done with this, but I'm still going to show you the kind of like the long way of doing this. So y dash would equal 7 multiplied by the 3, which is the power, multiplied by x to the power of 3 minus 1. So all I've done here, I should have actually done this, sorry. So what I should have done is y dash is equal to a times n times x to the power of n minus 1. So hopefully you can see the connection. So 7 is the a, so that's what that's going to be. The 3 is the n, and then we're doing 3 minus 1. So you're going to get y dash is equal to 21x squared. So, I mean, by the time, if you had done like level 2 calculus, when you look at it, you'll already know how to do this, because you multiply the power to the front and subtract 1 from the power. But you don't like, you know, when you do differentiation with these, you don't need, I'm going to put some line numbers here. So you don't actually need line 1 or line 2. You can go straight from here to here, and that's absolutely fine. All right, so what I'll do is I will do one more question, and then I will try and get you folks to do some practice ones actually. Now let's go straight into practice. Okay, so I'll give you guys 2 questions to try out. I'll leave the example up here. So try this question first. So we're gonna do 6x squared plus 8x. No, let's go, actually no, wait. Let's try 8x to the power of 5. And then question number 2 is going to be 6x cubed plus x. And question 3 is going to be, let's do something different here. Yeah, let's do this. So what I'd like you folks to do is try and differentiate that. So the time right now is 8:16. I am going to give you folks about, I don't know, 2 minutes. 2 minutes to try and do these questions, and then I'll go through the answers, and then we'll start progressively getting a little bit more challenging. Yeah, Elijah, I'm kind of missing the externals. Had a bit of a rush, and I know like a lot of folks asked me last year, like they were like, oh, can you do this for differentiation and calculus level 2 for the externals? So I thought, might as well start early. Yeah, I mean, especially if you're aiming for like, you know, any of the courses where they say you need to get those 3 externals, then yeah, I would say it's fairly important. Oh, nice. What topics have you covered, Elijah? OM Hinge, not necessarily, but I might do one question, 1 or 2 questions. I've already done a conics one, Elijah. I think there's heaps of, oh well, some of my old stuff anyway. All right, so I'm going to go through these 3 questions. Hopefully you've had some time to kind of go through it. Now, there's a reason why I put these 3 questions, because I actually wanted to write when I differentiated in different ways. So, and again, like I told you before, when you differentiate, you can write it as y dash, you can write it as dy dx, you can write it as f dash of x as well. So in this case, I'm going to write down y dash. Now, I'm sorry, but I kind of am going to go through this fairly fast. So if you miss out, don't worry, just ask on the chat what's happening, and then I'll try and explain to you. So one of the quick ways of doing this is, and I know if you've done, I know I keep repeating this, but if you've done level 2 calc, you would have known how to do this really fast. So I would just take the 8 and 5 and I'd multiply it together, which gives me 40. And I would actually reduce the power by 1. So right now the power is 5, which means I reduce it by 1, and I'm going to get 40x to the power of 4. That's pretty much it. Quick way of doing it, right? So question number 2, again, instead of y dash, I'm going to show you another format. So I'm going to use dy dx for this. So if that's the case, then I'm looking at the 6x cubed first. So I am looking at just this thing here. I'm going to differentiate that first. So I've got 6 times 3, which is 18. And then I've got x 1 less than 3, that's going to be 2. Then I've got that plus. Now, here comes the trick part, right? Anytime you have a like x to the power of 1, that's going to, when you differentiate it, it's going to become x to the power of 0. So the only thing that I really care about is the number in front of x. So because the number in front of x is 1, I'm just going to write that as 1. So question number 2, we should get 18x squared plus 1. Finally, question 3. Question 3, what we're going to do is we'll try f dash of x. And in this case, I've got 4 in the denominator, so I'm going to do this one extra step, right? So the power comes to the front, so I've got 4 times 3 over 4 x to the power of 3, because the power is reduced by 1. I should actually written this in different colors so people can kind of see what's happening. So now what I want to be doing is I just want to cancel the 2 4s, which means f dash of x is equal to 3x to the power of 3. All right, so what I'm going to do is I'm going to pause here and just ask you if there's any questions so far. If there are no questions, then I'm going to increase the level of difficulty. And we've got to go through chain rule after that, and then only we'll do exam questions. So on the chat, folks, let me know if there was any issues. Otherwise, you can just say move on. Let's go to the next set of questions. Man, super quiet. Okay, I'll assume that's a move on, and okay, we're good. Yep, sweet, cool. So next lot of questions, I'm gonna give it a little bit more challenging. So have a look at this. So you've got a little bit of algebra to do before you start differentiating, and this is where people end up making the most amount of silly mistakes. And if you can get this basic ones correct, you're going to be sweet with rearranging things. So I'll start throwing up a couple of these questions. So the first one is something like this. The second one is going to look like this. And the actually no, not like that, like that. And the last one we're going to do this. So what I'll do, once again, I am going to give you folks maybe about 3 minutes for this. So give it a go. Actually, no, I'm not going to give you 3. This is, you've got to go back to your level 2 algebra. I think if you remember your level 2 algebra, then you're going to be all right. I'll give you folks some time to give it a go anyway. I mean, who cares if you make mistakes? That's how you learn. All right, what I might do is I might just start going through these questions. So one of the rules about differentiation is that you've got to have the x in the numerator, and you can't actually have square root symbols around it as well. So in all three of these questions, we've actually got to change the format of what it looks like right now. So if you look at the first thing, we've got 1 over x to the power of 3. So what we need to do is, before we even start differentiating it, we need to do this. We're going to rewrite this as x to the power of -3. Now, if you remember this from level 2 algebra, or even level 1 algebra, when you bring a variable with a power from the denominator to the numerator, you've got to change its sign. So because it's in the denominator, it's +3. When you bring it to the numerator, it will become -3. So that's the first step that you need to be mindful of. What I'll do is I'll actually do all the transformations first, and then I'll give you folks some more time to try and do this question. So when you look at question 5, we've got square root of x. Now, square root of x, we can say that square root of x is the same thing as saying x to the power of half. That's just what square root actually means. And finally, for question number 6, we've got the 5th root of x cubed. So we write this as x to the power of 3 over 5. So I'll give you folks maybe a minute again to maybe try it, because if you get this part of it incorrect, then your differentiation is going to be completely wrong. So even before you differentiate these types of questions, you have to rearrange them so that you can actually have x in the numerator with a power and not any other symbols, and then you should be able to differentiate. All right, folks, you need a bit more time, or do you want me to start going through the answers? Let me know in the chat. All right, let's go through the answers then. All right, so having a look at question number 4. So we've got x to the power of -3. So that means when we differentiate this, we are going to multiply by the power, which is -3, x to the power of -3 and -1. So what we're going to end up with is y dash is equal to -3x to the power of -4. Now, folks, this is something to keep in mind. Like when you do these questions in your textbooks, the answers generally tend to have it in the simplified format, or what the original way the question was given in. Now, in the actual exam paper, you can actually leave your answer without actually simplifying it. You can actually leave it like this, and you're still going to get the full kind of marks for it. But for today's sake, we're going to do that one little extra step, which you normally wouldn't need to do for your exams. I'm just going to rewrite this as -3 over x to the power of 4. But you can actually just stop there for your grades in the actual exam paper. Cool. So looking at question 5, we've got y equals x to the power of half. So then y dash is going to equal a half multiplied by x to the power of half, and we're going to take away 1 from the power, which means we have y dash is equal to a half multiplied by x to the power of negative half. And again, this is where you could actually stop your answer. But if you do want to go further, you could actually write this as y dash is equal to 1 over 2 x to the power of positive half. And of course, x to the power of half can be said as square root of x. Finally, question 6, we've got y dash is equal to 3 over 5, which is the power that's getting multiplied in the front. And then we've got to do 3 over 5, take away 1. So we're going to get y dash is equal to 3 over 5 x to the power of negative 2 over 5. And again, you can actually leave your answer up to here, but just for this particular video's sake, we're going to move it all the way down, which means we're going to get x to the power of positive 2 over 5, and then y dash is equal to 3 over 5 and the 5th root of x squared. So I'm going to pause there, and if you do have any questions on any kind of any of these questions, just kind of tell me like, hey, let's actually do something like this. So you might say something like 1, 2, 3, 4. So 1, 2, 3, 4, 5. So you might say something like, hey, you know, can you tell me in question 6 what happened? How'd you go from like step 3 to line 3 to line 4? And I'm kind of happy to answer those questions. Joe, I'm assuming you're talking about level 2 calculus. Is that correct? If you are, then most likely I'm probably going to finish the differentiation one first. Yeah, I'll probably finish the differentiation one first and then start the level 2 calculus. Hoping to do it in week 6 maybe. At least that's the plan. Unless I get sick or something like that. All right, folks, if there's no other questions, let me know. We've got, what's the time? 8:30. Cool, 20 minutes, not bad. Do one more question, all right? One more question. Which one should we do? Yeah, let's do that one. Yeah, one more question. And then we'll go to chain rule. Okay, I'm assuming there's no more questions there, so let's go to question 7. All right, so question 7, you've got y is equal to 6x cubed minus 2x divided by x. So let's try this question here. A little tip for you folks, if you're trying to do this question. Remember what we talked about earlier before, like we always want to have this with x in the numerator. Now later on, you will actually learn how to differentiate when there's x in the numerator and denominator. But for now, have a look at this question. And the clue that I'm going to give you is something like this. Just give me a second. So if you have something like 7 plus 4 over 10, the hint is you can write this as 7 over 10 plus 4 over 10. So this is the hint for this particular question. Hopefully you can get the idea and then give it a go. See what happens. I'll give you guys 1 minute to do it, no longer than that. All right, folks, so let's start doing this question. So again, before I start differentiating, what I'm going to do is I'm going to separate the variables. I'm going to write this as 6x cubed over x minus 2x over x. So pretty much following basic fractions rules here. Because the denominator is the same, I can kind of write them as two separate fractions. Once I do that, what I can do is I can cancel out the x's on one of the fractions. And on the other one, I can replace this as a 2, get rid of this x. So what I've got here is y is equal to 6x squared minus 2. Once I have this, then things just become pretty straightforward because y dash is equal to 6 times 2 is 12. So I'm going to get 12x. Of course, 2 minus 1, that's going to be the 1. You don't really need to write the 1, but I'm just kind of putting that 1 there to show you what happened to the power. As for the minus 2, when you differentiate just a number by itself, that becomes 0. And you might be wondering, hang on, how did that become 0? Think about it. If we have y is equal to 7, we can say that this is the same thing as saying y is equal to 7 times 1. We also know that 1 is the same thing as saying x to the power of 0. So when we differentiate this, what we are doing is bringing the power to the front, 0 times 7, x to the power of 0 minus 1. And because we are multiplying by 0, everything is going to end up being equal to 0. So anytime you differentiate a number, the differentiation of that number is going to be 0. So in this case, our final answer is going to be y dash is equal to just 12x. All right, so our next step is actually, no, I'm going to pause there. Do we have any kind of questions? Are we happy with what's happening so far? Just give me some feedback before I jump on to our next topic. Is there any other question that you want me to go through again out of these 7 questions? I'll keep an eye on the chat. I know you guys are very quiet. Otherwise, you can just let me know. Move on. Yes, that's a yes. Move on. I can't remember what I actually asked now. I'm assuming that's a move on. You guys all good? Yeah, move on. Sweet. All right. I forgot as well because that's what happens when I'm trying to do like multiple things. All right, people. So this brings us to part 2 of today's session. All right. And I think this is where we're going to start doing a couple of questions and then we're going to go straight into exam questions. All right. So we're going to talk about chain rule here. So the thing about chain rule is, oh, sorry, hang on. Let me just have a look. That's no, this is, we're doing level 3 differentiation at the moment. Yeah, just did basic differentiation. But no, anyway, let's go to chain rule. So the whole point of chain rule, now I think people kind of can get a bit confused with when to use chain rule and so forth. I always like to think of chain rule as like, man, that's just looking like a lot of work there. Now let me give you an example, all right? So let's go with an example. Let's say this question here pops up. They want you to differentiate this. Now you're sitting there thinking, hang on a minute. How would you do this? Like, let me show you another one. Let's get rid of that. If somebody says differentiate this, automatically in your head you're going, oh well, I just have to expand it first. So I would do this. I would go x plus 4, and then I would expand that, which would make it x squared plus 8x plus 16, and then I would differentiate it, right? So when I differentiate it now, I'm going to end up with 2x plus 8. Now, that's great for doing this, but what if the question, like as I put before, what if the question ends up looking something like horrible, like this? All right. Now you can imagine it. You don't want to be sitting there and expanding this, multiplying 2x plus 3 like 8 times, because that's just insane amount of work. And then after that, you've got to collect all the like terms and blah, blah, blah. That's just too much work. No one's going to do that. And I think sometimes people forget what we do in maths. In maths, it's all about shortcuts, all right? We try and figure out shortcuts as much as we can. I guess that's why I enjoy maths so much, because it's like, I'm always like, okay, what's the quickest way of doing this? So anyway, this is where chain rule comes in, all right? And basically with chain rule, it kind of works. I wonder if I should do this with you guys, the proof, or just show you. What do you want me to do? Do you want me to show you folks the proof, or just like hit the chain rule? Let's go. Let's just get on with the questions. Proof for sure. All right. Let's do the proof. Okay. Do the proof first, and then we're going to do the shortcut, all right? So this is how it actually works. Now the problem is, when you look at this particular question, when it says, let's actually move here. When you see y equals 2x plus 3 to the power of 8, now you're going, no, I don't know how to do that. That's just too much work. So what you can do is you can do something like this. We're going to put u equals to 2x plus 3. And it doesn't matter. You can use any letter you want. But what I want to do is I want to actually put a letter that's not x or y. So I've done this, right? The next step is, what am I looking for? And this is why I don't actually use, in these cases, I don't actually use y dash. Well, you can, but for the proof's sake, I am going to use dy dx. All right, now this is what I'm looking for. By the way, if you understand this proof, it's going to help you a lot with rate of change later on. All right, some people go, oh, I hate rate of change. That's because they kind of never see the proof here, and that's why it becomes a little bit more challenging. But anyway, I'll show you folks. So we're looking for dy dx. Now the problem is, if I try to differentiate this function here, it's too much work. So instead, what I'm going to do is I'm going to put u equals 2x plus 3. When I do this, now I've got two equations. My first equation is this: y is equal to u to the power of 8. My second equation is u equals 2x plus 3. All right, hopefully you folks can see what's happening there. I've set up two equations. So I've said that u is equal to 2x plus 3. So I've substituted 2x plus 3 as u here. And then I'm doing u equals 2x plus 3 as a completely separate, another function. I'm going to differentiate y is equal to u to the power of 8 first. Now, this is why we do the dy dx kind of things. Because right now, when I differentiate u to the power of 8, I don't have an x, I have a u. So I need to write this as dy du. And when I write it as dy du, I am going to get 8u to the power of 7. All right, that's all I've done is I've just differentiated. I mean, you guys know how to differentiate x to the power of 8. If you differentiate x to the power of 8, you get 8x to the power of 7. And that's pretty much what I've done here, except the letter is u. Now, for the second part, I want to differentiate u with respect to x. So I'm going to write this as du dx. Now, when I differentiate 2x plus 3, all I'm going to get is just the 2, because, you know, 3 is going to disappear, the x is going to disappear, so you're just going to get the 2. Now, hopefully you folks can actually see the connection. I want dy dx. I can write this. Dy dx is what I want, but what I've got with me so far is dy du. Then I can multiply it by du dx, because what you'll see then is in the numerator you've got the dy, in the denominator you've got the dx, and because the du's are kind of like, you almost got to think about it like cancelling out. It's not really cancelling out, but that's the way we kind of think about it. So to differentiate this 2x plus 3 to the power of 8, you do this particular proof, and guess what? You've actually got dy du, which is 8u7, multiplied by du dx, which is 2. But a final piece of the puzzle. We want to write this as in terms of x, which means we've got to go back and replace the u. And if we replace the u, because remember, u was 2x plus 3, so we can write this as 8, 2x plus 3 to the power of 7 multiplied by 2. Now this is the kind of like the long-winded way, the proof way of doing this. Right? Now, I'm going to show you the shortcut. Because like I said to you, in maths, it's all about shortcuts. The shortcut way, wait, I'm going to pause. Does any of you have any questions about the proof so far? All right. Sweet. So here comes the shortcut method. The shortcut method works like this. To differentiate using chain rule, you kind of have to think about that whole bracket as like an x. So in your head, you're thinking about it like an x, which means you will write it like this. You'll go y dash is equal to 8 multiplied by 2x plus 3 to the power of 8 minus 1. And then in this chain rule, you have one extra step, which is multiplied by the differentiation of whatever's inside the bracket. Now, inside that bracket, you've got a 2x plus 3. Differentiation of 2x plus 3 is just 2. And guess what, folks? You are done, because you're going to get 8, 2x plus 3 to the power of 7 multiplied by 2. And as you can see, both of these answers are the same answers that you get. And that is pretty much what chain rule is. Elijah, I think it's because sometimes, when you see things the first time, your head is just going, what the hell am I looking at? And then second time, like for example, today, you actually made a choice to be here. And because you made the choice, you're like, I want to learn. So there you go. That's the difference. I mean, like, that's the same thing that happened to me in my school time when I was in class. So what I'll do is I'll put up one question for you folks to try and do it. See how it goes. So I'll leave this up here. All right, I'll leave this up here for you folks to try out. We're up to question 8, I think. Try that question. And then let's try this one here. Maybe some sort of bias. Look, to be honest, I think if you folks can get question 8 and 9 correct, I reckon we can actually start looking at some... Oh, actually, no, I'll do one more tricky question. One more tricky question. Number 10. By the way, question number 10 is an achieved question, I think, from one of the exams. Yep. Shone John, classic mistake. Everybody does that one. Beautiful, but you've got halfway there, Shone John. Remember that you've got to multiply by the differentiation of whatever's inside the bracket as well. Oh, son of a guy. Oh, that's lovely. They've taken out all the exam papers. Why would you do that? At least the good thing is I've got those exam papers. ln of x. Product rule. Oh yeah, nice. All right, folks. So let's start doing a couple of these questions. Or do you folks need a bit more time? What are we thinking? Hi, Kebsy. Welcome aboard. All right, folks, so chain rule, question 8. I'm going to go through the answer now. So, going to differentiate it, put the power in front, 7, 3x minus 1, and then I've got 7 minus 1, which equals to 6. And this is the part that people forget all the time with chain rule. They do this part beautifully, but they always forget to multiply by the differentiation of whatever's inside the bracket. Inside the bracket, you've got 3x minus 1. So when you differentiate 3x minus 1, you are going to get 3. And I just realized I got to go back to Shone John and I got to apologize because 7 times 3 is 21. Yeah, I completely forgot that you'd actually done that part. Apologies, Shone. So yeah, and again, you can actually leave your answer like this, or you could actually do that one extra step, which is 7 times 3 is 21. And you're going to get 3x minus 1 to the power of 6. So that's question 8 there. Question 9, again, same thing. Y dash is equal to, put the power in front, so 5, 3x squared minus 7x. Now the power drops by 1, so 5 minus 1 is 4. And we have to multiply by the differentiation of whatever's inside the bracket. And we always put whatever is inside the bracket that we differentiate, we also need to put that in a bracket as well. So when we have 3x squared minus 7x, we differentiate this, we're going to get 6x minus 7, and we're going to leave it like that. That's it. Basically, folks, what you've done is like an achieved question. Like this is pretty much a standard achieved question, a chain rule one that comes at the start of the paper. They usually do it as question 1A, 2A, 3A, any one of those combinations. And if you get that, yeah, that's like your straightforward achieved question right there. Question 10. So question 10, we kind of have to do what we did earlier in the basic differentiation. We're going to have to rewrite this as x squared minus 4 to the power of half. So when we differentiate this, we are going to get a half multiplied by x squared minus 4, and then we have to have a half take away 1 multiplied by the differentiation of whatever's inside the bracket. So we've got x squared minus 4, you differentiate it, you're going to get 2x. You can leave it like this, or you could, do a couple of extra steps, doesn't really matter. You're going to get x squared minus 4 to the power of negative half multiplied by 2x. Now I'm just lazy, I'm not going to put that all in the original format as it is. That's good enough. X squared minus 4. Yep. You folks looking, that's making sense there. Nice. Right, so we're going to do, I think we're only going to do 2 more questions and then we're going to be done for the night, folks. I just need to find it. Where did it go? Okay, here we go. This is starting to get a little bit more tricky now. So number 10 first. No, number 11. Number 11, what I'd like is, what can we do? Let's try this one here, number 11. And then number 12. Do we need number 12? Nah. I think that's how hard this question actually goes up to. I mean, I can give you one more harder one, but I think this is it. Now we're gonna stop at number 11. So try number 11, and then we should be done for the night. Glad it made sense, Echo. Now, folks, what we'll do is, like, every time we learn a new differentiation skill, we'll actually come back and we'll always use the chain rule again and again. So you'll pretty much remember it by the end of this series. Right, 30 more seconds, and then I'll go through the answer. Echo, that looks solid so far. -4, 3, -3. Yeah. Looks good. All right, let's go through this. We are going to do, before we start differentiating, we need to actually bring x to the numerator. So we're going to write this as 3x minus 5 to the power of -4. And then, yes, thank you. I just saw that, Hinge. Y dash is equal to -4 multiplied by 3x minus 5. Now remember, as as Hinge is saying, when we actually got -4, we've got to do -1. Yeah, I saw that -3 and I thought, even in my head, I was like, oh yeah, that looks right. What else? We've got to multiply by the differentiation of this, whatever is inside the bracket. Now that's equal to 3. So our final answer should be y dash is equal to -4, 3x minus 5 to the power of negative 5 times 3. And I know some of you folks have actually done this. Negative 12, 3x minus 5 to the power of negative 5. I think quite a few of us made that mistake. And that's how you lose that little achieved mark right there, because you added 1 instead of subtracting 1. All right. So I'm happy to give you one more challenging one, but other than that, we pretty much got the idea of chain rule here. Let me know. Yeah, that would be an auto cheat, which sucks because of that minus 3. Right, one more challenging one. Let me see this one. Okay, let's try this one. This is the last one, folks. Definitely the last one. Number 12. Y is equal to negative 20 divided by let's try that one. I'm sorry. I'll be honest. This is the last one. Good night, mate. Good night. Dog has finally gone to sleep. Quarter. Come on, folks. How do we go? What's the answers? Throw me some answers. All right, let's have a go through this question, yeah? So, we're going to do this first off. We're going to bring everything, before we bring it to the numerator, what we've got is y is equal to negative 20 divided by 3x minus x to the power of 4 to the power of a quarter. Then I need to bring everything to the numerator. So I've got negative 20 3x minus x to the power of 4 to the power of negative quarter, because the power changes when you bring it from the denominator to the numerator. Then we're going to differentiate. So y dash is equal to negative 20 multiplied by negative quarter, 3x minus x to the power of 4, and we've got negative quarter take away 1 multiplied by the differentiation of whatever's inside the bracket, which is 3 minus 4x cubed. Now, if I want to write this in a much more simpler format, I've got y dash is equal to negative 20 times negative quarter is 5. So 5, 3x minus x to the power of 4, negative 5 over 4 multiplied by 3 minus 4x cubed. Nice, we got a couple of questions there. Elijah, I think your negative is the one that... No, yeah, the negative 5. It should be positive 5. Right, there we go, folks. That's the first hour done. And that pretty much covers basic differentiation and chain rule. So it's not bad, not bad. We did a couple of challenging questions. So next session, what we're gonna do next session, we are going to cover, let me just have a look at what the next one is. So next session, which is going to be on Thursday, we are going to be looking at exponential equations and log equations as well. So that's the one that's like e of x and log of ln of x. We'll look at that on Thursday around the same time, 8 p.m. We'll do Thursday. Sounds good? I'll hang around for a couple of minutes, guys, just to kind of have a bit of a chat. Other than that, that's us for today. Thank you for coming. Thank you for participating. Appreciate it. All of this will get saved in a playlist for your revision later on. So if any of you did join us late, don't stress. Everything gets saved. Awesome. I might actually try and do a really quick one on Thursday before we do the 8 o'clock stream. So I just have to double check with a couple of things. 7:30, 7:45 we'll do like a quick stream for a couple of shirts giveaway, and then we no, we can't do it right now because it's like I'm actually saving this as a playlist. Not sure, Elijah. We might actually finish it quicker than 1 out of 15, but that's why I put it as question mark at the moment. When it's finished, I'll actually sort out the what do you call it, the thumbnails properly and the playlist properly. Cool. I will see you folks on Thursday. Yeah, like Awesome reminded me, we'll probably do a couple of t-shirt giveaways at 7:45, 7:30, 7:45, and then we'll get straight into this so we can get through exponential and log functions. All right. Till then, folks, take care and see you later. No worries, Awesome. The Sharpie's rubbing off. Ah, is that right, Elijah? Oh, I need to come up with another plan. I did, I think it's probably, I need to sign it inside, rather than the outside. Yeah, shout out to you, Sean. What, this one? Oh, mate, this is... I'm not gonna lie, Awesome. I actually went a bit crazy with my t-shirts. I bought about 10 different colored t-shirts and just put all Infinity Plus One logos because you know, you folks know I've got my own machine here for t-shirts, so I just went a bit crazy. Echo, I like, it depends where you're at, and if I visit your school. What is it? When's next meet the students when? Hinge, I don't know. Like I thought about a couple of ideas. I was like, oh, maybe I should do one in I don't know, like library or... Oh, just pop over, Echo. What are you talking about? I'm there tomorrow, whole day at OJC. Oh, Elijah, yeah, no, I think we did talk about with Miss O'Graham that might come back for another quick visit sometime in term 3. Hinge, where are you based? Are you based in Auckland or? Oh, West Auckland. Costco side. Now, I think I've got 2 visits. I'm trying to work out a visit with a couple of schools. Just waiting for the teachers to confirm, and then yeah, I should be able. I'm gonna come down. Hinge. It depends what school you're at. Hinge. I would say just talk to your teacher and just say, look, can we invite that guy to come and visit our class? I'm happy to come and visit your class. It's not like I charge anything or anything. You know, just come in my non-contact. Come and say hi. Talk to a few of you, and then be gone. Which school is it, Hinge? Which school? Rutherford. Rutherford College. Who is your maths HOD there? Let me find out. I should really not be streaming part of all of this, but I'll edit it later. Worst case scenario. No, I don't know who that is. Might have met the person. No, let's have a look. Wow, you guys actually have photos as well. Oh, no, you don't. Yeah, Hinge, just chuck us a message and then we'll actually go from there. Happy birthday, Maury. Happy birthday. Anyway, folks, look, yeah, like as I was talking to Hinge, if you do want me to pop by and just say hi to you in your class, just get your teacher to just email me. My email's under there somewhere. I'm happy to come and have a chat, have a bit of a banter and a bit of a laugh. I'm happy to do that. But yeah, as for now, I've got to get going. I've got a bit of a long night ahead with some work. I will see you folks on Thursday for part 2 of this series. Yeah, I'll catch you later. Bye.